Yeah, hello everyone. So today we are going to discuss one of the very important and interesting question you can face anywhere in VLSI design, in a no circuit design especially. So here, what we have given two circuit, common source amplifier, Vin, and we have to plot the GM of both these circuit with respect to change in Vin value. So let's see how these two are different and how they are, you know, which one is more important, why. We will see that. So here we will see we have to calculate, draw change in GM of the circuits, not MOS because circuits, with respect to change in Vn. We are changing Vn from 0 to VDD, then how our GM value will change. Now we will see for the first case, this is the first, this is second solution. For the first case, GM of circuit is equal to GM of the MOS. Okay. So here GM has three formulas to note. GM is mu n cox W by L into VGS minus VTH. Number one. It is also equal to root 2 mu n two mu n cox W by L into ID. Third is 2I drain upon VGS minus VTH. So depending upon the value we are varying, like we are varying VGS or W by L or ID, we we can use this GM formula. Sorry. So like if your W by L is constant, VGS is varying, we have to use this formula. If our ID is constant, W by L is varying, we have to use this formula. Or W by L is constant, ID is varying, then as well we will use this formula. Our ID is constant and our VGS minus VTS is varying, then we will use this formula. Now here, for this particular case, now our Vn is varying. So Gm is equal to mu n cox W by L VGS minus VTH. This formula we will apply because our VGS is varying. S is constant, Vin is changing, it means Vg change because VGS is equal to Vin minus Vs and Vs is 0 here. So this formula will become mu n cox W by L Vin minus Vth. So it means Gm of this circuit is simply linear function of which will start from VTS because Vin should be greater than VTS, then only this will on, and after becoming on it will reach to saturation and GM will increase linearly with respect to Vin, but up to certain value of Vn, because after some value of Vn this will reach to active region. This is saturation, up to this it is in saturation, but after some plain value of Vn which will be equal to VO minus VO plus VTH, when Vn will be higher than Vout, then and how much it will be higher than Vout, higher than VTH value, then it will reach to the active region, and in the active region this will fall like this. Second circuit, which is common source amplifier with degenerative resistor Rs, and this is Rd, and here our Vn is changing. So in this case, Gm of this circuit is not simple Gm of MOS used, because as Vin increases, ID will increase from the ID is equal to mu n cox W by L VGS minus VTH equation. So as Vin will change, VGS will change, ID will change. If ID will change, then your source will also increase. So it means this source is changing, increasing, VG is increasing, and this change in Vs value is equal to ID into, it is depending upon this Rs. So now our VGS here is equal to Vin minus Vs. What is Vs? Vs is ID into Rs. Now VGS is equal to Vin into ID. What is ID? ID of a MOS is GM of the MOS time VGS of the MOS into RS. From here, Vin will be equal to VGS to 1 plus GM into RS. Now, the capital GM equivalent of complete circuit will be, obviously, GM is transconductance. Transconductance means not transfer. Conductance, obviously, I by V. Because it is transfer, so I is output and this is V. So here, because we have here V is equal to this V, and IO is ID drain of the MOS is same in the complete flow, in the complete circuit. I is same. This is ID, which is here. So it will be GM into VGS, which is due to change it upon V is 1 plus GM RS into VGS. So VGS cancel, and this is from here to here. We are going GM of the complete circuit is this. So from here we have GM equivalent is 1 plus GM into RS. Very important thing. GM I'm denoting by capital G. If we just divide numerator denoted by GM, it will come plus RS. Now, when we are changing V in, how to draw GM? How GM will change? Initially, this GM 1 by GM, because GM is low, so 1 by GM will be, when 1 by GM greater than RS, then this is equivalent to GM. So it means at the starting point after VTS, it is linear as it was in the previous case. But when our RS will be much higher than 1 by GM, because GM is increasing, okay, GM of the MOS is also increasing with V in. So 1 by GM will decrease, RS is fixed. So one time will come when RS will become greater than 1 by GM, and at that moment this GM will become constant value 1 by RS. So after certain value, our GM will become 1 by RS. So now this 1 by RS is our GM. So obviously after some time it will reach to the active region, then then in the active region RS 1 by RS and the R on of that MOS will give the effective GM. Okay. Now what is the application? Now if you will see, AV of such circuit will become RD into GM, and in this case it will come RD upon RS. So the effect of MOS which is coming due to GM will completely will not come here, because your gain is now completely depends upon RD upon RS. So that's why we need very high RS to make AV less dependent upon the MOS parameter. So now your gain will be much linear gain, much stable gain, because your AV is not depending upon the parameter of the MOS. So we have other advantage of this, but we will discuss this in some other video.